So let's start with a demo. Here we have a demo application that will show us where to add JavaScript, some extended properties in jQuery, and Silk UI. Now, in this set of demos, for places to add JavaScript, each Run button will trigger a different alert message that states where it is running from. So for the JavaScript in the module demo, I hit run, and there is a message saying I'm JavaScript in the module. In the web screen, it says I'm JavaScript in the web screen, and so on. In the web block, I'm JavaScript in a web block. In an external file, in the run JavaScript action, and in an expression. So that's it for this part of the demo. Now, how does all of this work? Let's look at the actual source code for this demo. So we're going to begin with JavaScript in the module. Now, every single button in this part of the demo works pretty much the same way. So if I open this up, I can see here the click properties for this button. And this is a navigate button, so it's going to navigate to a screen or to a URL. And here I select that I want to navigate to a URL, to an external URL. And the URL is just the hash. Now, when a URL is just something that begins with a hash, that tells the browser not to navigate away from the page, but rather to scroll inside the page to an element that has this particular ID, such as my list. If I don't specify an ID and I just use the hash, this tells the browser to scroll to the top of the page. So this ensures that if something goes wrong in my JavaScript code, then the button will simply scroll to the top of the page. This is a common web development technique in these kinds of buttons to ensure that there are no side effects, the page is not left, the browser doesn't leave that page when the user pushes a button and there's something wrong with the JavaScript. So this is the basis for every single button here. If I click on each of them, you can see that these properties don't change as I keep clicking on each of them. Now what does change is this extended property here at the bottom, as you can see when I click through each of them. Now the extended property that I'm using is an onClick property. Extended properties are generated as attributes for the HTML tag that generates this widget. So there's an HTML tag that generates the button, and this is telling me that I want an onClick attribute in that HTML tag with this value. Now, as I'm sure you know, this means that when this form element, in this case this button, is clicked on, this JavaScript will run. That is how an onClick attribute operates. So each button is doing a very similar thing. They call a specific function, in this case JS in expression, here JS in run JavaScript action, here JS in web screen, and so forth. So each of them is calling a different function, but they all end with false, return false. They all end in return false. Now, what does that mean? In the specific onClick event, if the event handler explicitly returns false, then the usual behavior of that element is cancelled. If it returns true, then the usual behavior of that particular element applies and is executed. So the onClick will run before the usual behavior of the button. So The usual behavior of the button is defined here, which is to scroll to the top of the page. So basically what we're saying here is that we don't want the browser to scroll to the top of the page. If we had some other behavior, some other URL, a return false would say that we don't want the page to be navigated to that URL. A return true says that we want the page to be navigated to that particular URL, and so forth. So what we have on all these demos is a button that, just in case, doesn't have any special behavior. It doesn't leave the demo page. And when you click on the button, it runs a specific function and then returns false to ensure that the usual behavior of that button is not triggered, and actually not even the scroll will happen. So what we need to find out for these demos, these 6 demos, which demo where can we add JavaScript in the OutSystems platform, is simply to figure out where are these functions defined. The function for the module, the function for the web screen, the web block, external file, run JavaScript action, and JavaScript in expression. For the module, we have that function defined globally in the module itself, and that means that it's in this top item here in the tree. In this top item, we have several module-wide properties which apply to the entire module, and one of them is this property here, which is a JavaScript property. This is a property that includes JavaScript code, and this code will be added to every single screen that is defined for this module. So if I double-click on the JavaScript property, I have a JavaScript editor with syntax highlighting that I can use for my JavaScript code. So when I push this button here, this calls JS in module, and this is the function where JS in module is defined, and the alert message has the corresponding message that shows up on the screen. I'm JavaScript in the module. And the same thing applies for the other demos. So for a screen, we obviously go to the screen and we find the corresponding property. Here we go, JavaScript. And I can define my JavaScript for the web screen right here. For a web block, I can also do the same thing. So I have here a web block defined, and I just find the corresponding JavaScript property, and I have here my JS in web block function with the corresponding alert message. However, if this JavaScript is to work on the main home page for the demos, then I need to include this web block in the home page. I'm going to scroll down to see if it's here, and apparently there's a message here that says that JS web block is included here. And in fact, this blue title here tells me that the web block is here, JS web block. Okay, now how did this text show up here? How did I manage to show a text that tells me that a web block is present here? Because when I go over to the page, to the demo page, there is no text here. Nothing is showing up. But in the canvas, in the editor canvas, I can see this one as well as many others. Now the technique for each of these items is different. For a web block, let's take a look. Let's double click and go into the web block. And I can see my text here. So far it's pretty trivial. However, how did I do this? Because if I insert text, it will show up on the published application as well, and it doesn't. Now the clue is this sideways square here, condition false. This means that there is a condition here. I currently have this selected to show the true branch only. I'm going to select to show all branches. So I have a conditional here, and in the true part, which is the top square, I have this text. In the false part, I have nothing. And if I go over to the condition of the if, which is right here, I can see that the condition is always false, which means it's always the bottom square that is displayed when the application is running. So nothing is displayed. However, in the canvas, I can see all options, or one of them, just by selecting here, on the canvas editor itself. So I can see this text to tell me that I have a web block right there. Otherwise, this would be invisible and I would not be very much aware that the web block is there. This is a common technique used in the OutSystems platform to perform this kind of documentation, visual documentation of what you're doing in the canvas alone. The compiler is smart enough. He sees that a condition on an if block is constant, doesn't change, and therefore he only uses the correct branch when compiling and generating the code. So even the condition itself disappears when the platform is compiling the code for the environment. So going back, this is JS in WebBlock, which we have here, and it works because it is included in the home page. And then we have a few others. So we also have JS in external file. Say you have a file with some code that you want, with some JavaScript code that you want to add to your application, to your module. In this case, we have this demo file here, which has this content, this function JS in file, and I'm JavaScript in an external file. How do I include this JavaScript in my module? Now, there are several ways. One of them, the simplest one, is simply to copy and paste it into the correct property, either in the module, screen, or web block, or you can just add this file itself as a resource for your particular module. So what we do is come over to Data, scroll to the bottom, right-click, Import Resource. This shows up a list of files which you can select, and then you select the file that you want and it becomes part of your module. In this case, we had previously selected demo.js. Then it's important that you select the deploy action to deploy to target directory. The default is do nothing, so it becomes part of the module itself, but it's not deployed to the target directory. You want it to be deployed because you're going to use this file in your code when you're running the application. So it needs to be deployed to the target directory in the web server. And now we can access this file. But as you very well know, in order to access this file, we need a special script tag in the header of our generated HTML that states, I have an external file called demo.js, please include it. How do we do this? Let's go back to our interface and to our preparation. And here we have a built-in block which is called add JavaScript tag. And this JavaScript tag does what is necessary for you to include that file into your code. So I specify the JavaScript URL, in this case demo.js, and I can even set the defer attribute to be sure that it will only be loaded at the end of everything, after everything else has been loaded, to ensure that latency, visual latency for the user is as low as possible, and even specify the character set of my code if I wanted to. And this will add a JavaScript tag to the header of the generated HTML with this information. And therefore, this file becomes included in my screen. This is in the preparation for the homepage screen. And once it's included, when I run it in the demo, which is this demo here, the function is invoked and I get the proper feedback. So run, and I'm JavaScript in an external file. I can also run JavaScript from a run JavaScript action. So in the preparation, I also have another demo action, which is run JavaScript. And it works very similar to other places where you can add JavaScript itself. So I have this action. It has an input argument called script. And here I type my JavaScript script, and this becomes embedded on my screen. Now, whenever you're using an action, even the built-in actions, they can have input and output parameters or arguments, but their data types is one of the basic data types, and you don't have a JavaScript data type. So the closest thing is a string data type, and this is what you're seeing here. My JavaScript is encoded as a string, so you need to start with a double quote, end with a double quote, and every time you need to use a double quote in your code, you need to repeat it twice, otherwise it's interpreted at the end of the string. You don't get syntax highlighting in this case because this is a textual string and the editor can't figure out that your intention was to have JavaScript code inside this string. So this is a bit of a nuisance. Unfortunately, it's not as easy to generate JavaScript here, but it also shouldn't be a necessary thing unless you want to use a conditional in the preparation to decide whether or not to add some JavaScript to your screen. So going back to the home page, we finally have here JavaScript in expression. The final place where you can add JavaScript is in an expression widget, which is right here. If you drag an expression widget anywhere on your screen, in our case we dropped it here, then you can specify JavaScript there as well by using this feature, escape content set to no. By default, expressions expect the result of the expression to be displayed on screen. And even if that result includes special HTML characters such as less than, greater than, ampersand, and a few more, then those should be encoded or escaped somehow so that they still represent themselves rather than retaining their special meaning. This is what an expression widget does by default. It escapes content, and therefore everything that belongs to the result of this value, expression, is displayed as is the result. However, if you actually want to leave the special symbols for their special meaning, i.e. you want to insert HTML code, such as this one you can see here, script, then you need to set escape content to no. Beware, however, this has dangers in terms of code injection attacks, so you need to pay some attention to this particular feature. So my code is right here. Again, this is a property of a built-in widget. There is no JavaScript data type, so it's a string. There is no syntax highlighting. And it's the same thing as we saw earlier, with the exception that now we're inserting HTML, and therefore we need to tell the browser that here begins a script and then here ends a script. And these are the tags that we're going to use for that. In the middle, we have our script, as expected. Function JS in expression. And when we call that function, of course, that code is run. So these are the options for where to add JavaScript. So what else do we have here in our demos? We have extended properties and jQuery. In this section, we're going to show you some typical features and functionality of JavaScript, such as typical on key up, on blur, and so forth, many events, and also how to use jQuery directly from the platform. Now, the main thing actually you're going to learn here is this. It's summarized right here, which is how to identify widgets by their ID. The platform generates IDs dynamically, and you cannot specify them manually. When you set a name for a widget, you're simply setting it so that you can read its properties or access its properties from code. You're not setting an actual ID with that name. In order to reach that widget's ID, you need to use this syntax, widgetName.id. And this is what you would insert into a getElementById call or a $call for jQuery. We're going to see this in a second. Let's start with the first demo on click and submit. Now, these two buttons actually send different text to the server, and the server then responds with a notification message with the same text. So this button will send ping, this will send pong. So if I click here, it goes to the server, and we get a response back ping. If I click the other one, it goes to the server, and I get a response back pong. So just a quick note, the previous examples were all running locally. You can see here, especially in this icon here, an animation when the browser is trying to access the server. And this does not happen in any of these calls. When I click here, please notice this part of the screen here. There is no animation there. However, when I'm running this demo here, send ping, note the animation. Here we go. And the screen obviously refreshes. So here I am sending data to the server and the server is replying. Let's see how this works. So let us scroll down to the other demos, and these buttons actually send something to the server. So they're no longer a navigate method button. Their destination is a screen action called echo. Screen action is found here. Let's go back to the button. And the screen action has an input parameter, which is input text. It's a text data type. And of course, I'm passing to this input text a text on click, which is a local variable, which is also text. Now, the interesting thing here is that I'm assigning to this local variable a string when I push this button, and I'm doing it in JavaScript. How do I do that? Well, I have a hidden input right here, and I'm going to change this input. This input is assigned to the local variable, so when I change this and go to the server updates the local variable. And this is what the button is doing. I'm going to come back to the button in a second. So this is an input field, a hidden input field. And it's hidden because its style extended property is set to display none. Now, we can't hide input elements, input widgets, by setting visible false. And why can't we? Because we want them hidden and not away from the page. And if we set something to visible false, then it's no longer present in that page, in that screen, when it's generated by HTML. And we want it to be there so that we can access it with JavaScript. Except we don't want it displayed, and this is why we're using this HTML attribute style with this value, display none. Now the input has a name, text on click input, and in the button With JavaScript, I have an onClick event which assigns to text onClick input .id the element whose ID is just that, to that value, the value ping. So this would get me the input object from the DOM. It will identify this particular input object from the DOM, the document object model. And then I'm accessing the value property of that object and assigning it the string ping. And now what's interesting is that this onClick now returns true, which means that whatever is the default behavior for this button, for this element, it will happen, is supposed to happen. In this case, the default behavior is to submit the form to the echo screen action. And this is what will occur. And of course, the send pong is the exact same thing, except that it's using jQuery. So again, this identifies the input widget from the DOM and returns a jQuery object that I can use. And I'm using jQuery's val function to change its value to pong, and then return true. It's beyond the scope of this masterclass to teach you how to use jQuery. So this is actually jQuery syntax, as I'm sure that you know. But the main thing to learn from this example is that you can use jQuery right out of the box. And why? Because it belongs to the platform. Let's go over here to the module definitions. And one interesting property we have here is jQuery version. Now, I have two options. I can use the old jQuery used by OutSystems. I can use one of the latest. Try to avoid changing this. This might break some widgets. And these are the ones that you can use by default. You can also install your own jQuery, and that will still work fine. So, to recap, send ping. OnClick changes the value that's typed here to a specific string, which is the string ping. Here we go. As if the user had typed ping in that form input widget. The onClick event then returns true, which means that the default behavior will occur, and the default behavior is to submit the form to the echo function, and it passes the text onClick local variable, which is the local variable assigned to this input, and therefore now will hold ping. It will assign again this local variable to the input of the screen action. If I double click on my screen action, all that happens is that there will be a screen feedback message with the text specified from the input, and it's a success feedback message. It's that simple. Moving on to onKeyUp and onBlur, let's look at the demo. Here, we're going to be able to type some text, and while we type, the text that we type is showing up here in front of onKeyUp. OnBlur doesn't have any effect until we click anywhere outside this box or use the tab key to move outside this box. So if I click in the background here, then onBlur shows what I've typed as well. If I keep typing, then the same behavior applies. What I type shows up in onKeyUp, onBlur does not until I click elsewhere. So this is simply how to demonstrate how each of these events runs. As we're going to see, both of them are the exact same JavaScript code. Then they change an expression that is present here in front of each of these bold text headings. But each event handler will run in response to different events. So the top one will run when a key is released, when it's up, and the bottom one when the input widget loses focus. And this is called the blur event. So this means that if we hold a key down, you're going to see that the key is going to repeat here, but the key will not show up on the onKey app. Only when I release the key will onKey app be updated. And even then, onBlur will not be updated. So I'm going to hit the X key, hold it for a while, and then release it. And note that while I hold it, nothing shows up here. When I release it, all the X's are going to show up here. So I'm going to press and hold. So pressing, release. And there we go. Now the X's are here, and as soon as you move the focus away, in this case with a tab key, the onBlur event occurs and the text is also copied to this location. So let's see how this works. As expected, we have on the input item these two extended properties, the onKeyUp and onBlur, and they have almost identical code. So what I'm doing here is copying this thing here onto this thing here. So I'm copying the text onKeyUp and blur input to text keyUp expression. So let's see, what are they? Text onKeyUp and blur input is this input here. And each of these expressions also has a name, text keyUp expression and text blur expression, as you can see on the right hand side. And these actually are divs or spans in HTML. They are identified with their own ID, and I can access that ID from my code using the syntax you're now used to. So going back to the expression, I'm copying the input over to the expression. So I'm locating that input. jQuery returns an array. I only want the first and probably only item, and I'm reading its value. And I'm copying again to the expression. Again, it should be only one, but I'm getting the first result from this array, and I'm copying it over to the inner HTML. And in this way, whatever's being typed in the input is going into the actual expression tag. Note, however, that because this is being done dynamically, the escape content property, which is yes for both of them, doesn't have any relevance, because this is done by the server when it's generating content HTML to be sent to the browser. It doesn't work live during JavaScript execution, which means that when I run here my code and I use something like this B is now bold/B, if I type HTML, because I'm copying this to the inner HTML property, these symbols are being interpreted as HTML code rather than being escaped or encoded as it would be normal using an expression. Beware of this situation. If you're using inner HTML or similar attributes from the DOM, then be careful that the platform can protect you as to what you're doing, and you're copying a value directly over to the inner HTML, and therefore anything in that value that can be interpreted as HTML will be interpreted as HTML, and it will have side effects. This is called a code injection attack in this particular situation is really not relevant at all, because you're simply ensuring that what you see here has some odd side effects. And this on its own has no bearing on security, unless, of course, once you take this string and send it elsewhere, you still interpret it as HTML and it has some other effects. So, this is onKeyUp and onBlur. We also have an onKeyPress demo. Let's take a look at how it works. If I'm now typing something here, and I hit enter, the system responds with what I've typed. Even if I keep on writing and hit enter again, it still responds with what I've typed. So now this only happens on key press. It's a different event. Let's take a look at the code. Again, it's similar to the previous one. On key press extended property with some code. Let's double click. And sometimes the expression editor scrolls down to the bottom by expression, and it seems that my expression is empty or almost empty. This is not the case. You just need to scroll up to see all contents. And here we go. We have JavaScript as my expression. And here we're checking what is the key code that has been pressed. And there are slightly different ways to do this depending on the browser. This code merges those two different ways, so that if I have access to event which, I'm going to use that. If I don't, I'm going to use event key code. And if the code is 13, which means enter, then an alert message is triggered, and it will display the value that's on text on key press input, using the usual syntax we've seen earlier. It will then return false, which means that the default behavior of pressing enter on an input item is not to be triggered. What is that default behavior? When hitting enter on an input item in a form, that will submit that form. And this is not wanted in this particular situation. So we want to return false so that that default behavior does not occur. If this is not true, then I did not return. And therefore, I simply return true, meaning that whatever is a default behavior for other keys should be triggered. And the default behavior on an input widget is to show that key on the screen as part of the input widget. Finally, onSubmit in a form does not work in the OutSystems platform. This is not a limitation of the platform itself, it's a side effect of the underlying technology, of the .NET technology. Now, you can have multiple form widgets that you can see here on your screen. The same way you can have multiple form HTML tags on each HTML page that you want to create on your own. However, the underlying .NET technology always generates a single form for your entire screen, and all data is passed from the screen to the server when you push any button on any of your supposed forms. This means that you cannot have a separate form tag for each of your forms, actually. And this is because HTML forbids you from having nested forms. They will not work properly. So actually, when you are dragging a form to your screen, and we have a form here, as you can see from this label, the platform does not generate a form tag here. It generates a div, an HTML div. And an onSubmit extended property, i.e. a generated onSubmit attribute on a div, doesn't do anything. It doesn't have any HTML meaning, and therefore the browsers will ignore that attribute. And that is why a form onSubmit doesn't work. It's a side effect from the underlying Microsoft .NET technology. So in this example, we have a form. Inside the form, we have an input and a send button. Now, the send button sends to the same echo screen action the text that was typed in this input. This input is assigned to session record on submit text to send, and of course the same variable is assigned to the input of the echo screen action. So in theory, we type something here, we push send, and we get that same something as feedback from the server, much like happened when we pushed send ping and send pong, except that this time we select what's being sent, not just ping or pong. However, in the form, we do have an onSubmit extended property. And this should run when the form is being submitted. In this case, when we're pushing send. And when that happens, we should have an alert stop and a return false, which should prevent the form from being submitted. And we're going to see that neither the alert is displayed nor is the submission prevented, which means that whatever we type here is going to show up on the screen as a feedback message. So I'm going just to type anything, and as soon as I hit send, this does go to the server and we get anything back. And that's it for extended properties and jQuery. Another demo is Silk UI. This set of demos shows us some of the additional widgets and functions available in Silk UI for us to use JavaScript. Now, some of these allow us to insert JavaScript into our screens in slightly different ways. One way to do this is with a script function. So we push the run button here, and I am JavaScript in Silk UI script function. So there we go. How does this work? The script function actually simply surrounds the code that I provided with a script tag. So it's going to be used with an expression. So double-click on the value for this expression, scroll up, and it's the exact same expression as we saw earlier, with the difference that we have a script function here around our JavaScript code. And this ensures that the proper script tag is being inserted around this JavaScript. Now, for the next demo, there is a ready function. Now, the ready function will surround again JavaScript code with a special jQuery call to ensure that the code that I specify inside the ready function will only run when the DOM is ready. In this example, we're going to use that function to hide this button that does nothing. Now the function runs automatically as soon as the DOM is ready, which means it runs as soon as the page loads. So in the demo, there is no button because it has been hidden. So let's go back, scroll down, and we have here an expression with a ready function. We double click, and the principle is very similar. We have the script function around our code. We have the ready function so that we're generating JavaScript, which will only run when the page is ready. And the JavaScript itself is again another function call. In this case, the JS_hide function call. This one also belongs to Silk UI, and it generates JavaScript that hides a specific HTML element whose ID we give it as an argument, as a parameter. And here we go. So what we're doing is hiding the button ready when the DOM is ready. So let's see, button ready is of course this button, correct, button ready. And the button by default does nothing. So let's triple check here, navigate to an external URL, which is just a hash, and the onClick function even simply returns false to ensure that it really does nothing. And as we can see from the demo, it seems to work as the button is hidden. Now the opposite function to this is the JS show function, which does the reverse. It shows an HTML element. And this one is set up so that we show this button again. So when I click run, the button is displayed again. And this button, if I click on it, as you can see, really does nothing. So let's see how the JS show function works. Let's go over here. We have the typical button code that does nothing, and the onClick external property is a JS show with the button ready ID. And I'm concatenating the return false to that particular call. And that's it. So I'm using a function that generates some code for me. Now we have many other functions from SilkUI that generate JavaScript for me for doing common functionality. One of them is sampled here, the add class function. When I hit run, it will add a class to this button element. It will add the button default class, and therefore the button will look like a default button even though it is not. So I'm hitting run, and there we go. The button now has an additional class, style class, assigned to it. There are many other functions in SilkUI for doing these JavaScript operations, and we can see them here. So SilkUI framework, JavaScript, and these are the available functions. Add class, pretend we clicked something, hide and show, set iframe source, besides of course the ready and script functions that we saw earlier. Finally, we have another way to add JavaScript in our screen by using a JS widget. So the demo is very simple, as you must expect. I'm JavaScript in SilkUI's JS widget, and we've added it on the screen right here. Now it's very similar to an expression in the sense that you have an input parameter, and here you have your JavaScript code, again because this is a web block that is being used to generate this. This is an input argument. There are no JavaScript data types, so the platform doesn't know that this is JavaScript, so there's no syntax highlighting. You have to use the double quotes and so forth, but you place your JavaScript code here. And furthermore, you have a placeholder for text that describes what this JS widget is supposed to do. So this works a bit like the trick that we saw here in our JS web block, where we added some text here with the if block and so forth, except it is all automatic in the SilkUI JS widget. It's also much more elegant on the screen. It provides proper canvas feedback for what we're doing, and it's therefore a better approach than typically to use your own JS web block. What would be the exception? Well, if you have lots of JavaScript code, it's easier to have it with syntax highlighting, as you can have it here. Furthermore, actually all of these external properties that when we open up show a syntax highlighting, the platform knows that they are JavaScript, and therefore it generates an external additional file where this code is written. And this JavaScript code is then added to the screen that is being generated with a script tag. The advantage being that the first time you access this on a web browser, the web browser loads the additional resource, but then it caches it internally in its own cache. And the second time you return to the screen, that file and that entire code is already there. That doesn't happen with all the JavaScript that you type that is a string, because that needs to be added to the actual HTML that is generated and therefore becomes part of the code that needs to be downloaded from the server each single time you visit that screen. So here we have our SilkUI framework widgets, And in development, you can find multiple web blocks, as you can see from their symbol here, that you can use on your screens for development. There's one for CSS, for HTML, for JavaScript, which we're using here, and of course jQuery, which works in a very similar fashion. I just drag it here, and I have the jQuery widget right here. I can set a description and of course change its JavaScript code to anything I'd like. Hopefully something that makes sense, not this. Now, what is the difference between a jQuery web block and a JS web block? Actually, none. It's just the graphic that is displayed in the canvas. So hopefully, if you're trying to write your code in a way that's easier to understand, which would be a best practice in any development platform and also in the OutSystems platform, then you would use this one if you're writing jQuery code and use this one if you're writing plain vanilla JavaScript code. But you can, of course, mix them up at will, and the platform will not validate what kind of code you have on each. And that's it for our demo. Now we also want to see how to integrate an external JavaScript framework on a module or an application that we may have. And for this, we're going to take a forum post that explains this from my colleague Hugo Caterino, who provides a sample OML file that I'm going to show you. Now, the example here is to integrate this JavaScript R carousel into our application. And the idea is to get to this result. So we have this carousel here with scrolling images available by integrating that JavaScript framework. So how did we achieve this? Well, the idea is simple. Based on what we've seen previously and what we know for where to add JavaScript into the platform, we're just going to follow instructions from the R carousel page on how to install and use this framework. So we start by scrolling and getting started, compatibility, maybe the getting started. I'm going to click here, and here we go. The getting started starts telling me how to add my framework to my screen, to my pages, or to my application. So we need to include some scripts, as we can see here. Now, first of all, we need to download the zip file from this framework and start opening it. So I have it right here on desktop, and this is a zip file from that framework. If I enter the zip file, I have an examples in the widget folder. Inside the widget, I have a lib folder, and inside it, I have the JavaScript file that I need. And that is exactly what is in the manual from that framework. In whichever path you extract the zip file to, you have a widget, then a lib, and then several files. So the idea is to take each of these files and place them on our module. Now we could do this as external files. That's a bit harder. It's always visually better to use web blocks for this, because with external files, with resources, you would need to go to the preparation and include an add JavaScript tag action to include your files. So it's easier to just place this on a web block. The platform will automatically place your JavaScript on an external file. You just need to copy and paste the content of these files onto the actual web blocks. So here we have the minified version, but for example purposes, we're going to include the non-minified versions of this code. So let's open the main flow, and we start creating web blocks for each of these files. And on each of them, we have this small text here that tells us on the canvas alone what is being inserted for each screen. This is using the technique that we've seen earlier, which is a condition that is always false. So the JavaScript property is the copy and paste of the jQuery code itself. Now, of course, you may wonder, now, doesn't the platform include jQuery itself? It does. If you can at all avoid including a second jQuery framework onto your screens, please avoid it and don't include it. But if you can't avoid it, jQuery knows how to handle multiple versions of itself running, and you can do this. Same thing happens for jQuery UI core and then for jQuery UI widget. All of them, what really matters in these web blocks is the JavaScript that's here and that we've taken from each of these non-minified files. So here we go, jQuery, UI core, UI widget. And then we also need UI carousel. And this has been placed in this web block. So our carousel, and here we have our JavaScript for the carousel itself. But the carousel itself needs further things. So we also need to add a style sheet, which is defined here. Now you just open this file and you copy and paste it to the style sheet property of the web block. Here we have some fixes for this particular screen, as well as the style sheet that was present in the actual JavaScript framework. And then, in order to create the carousel, we need this HTML structure. So it's a div with a specific ID, and inside it our images. That's it. Now we can replicate this in the platform by using a container, which generates a div, and images, which generate the image tag. And that's just what we have here in this web block. If we go over to the widget tree, we have a container, which is named carousel. This is not the ID that it has. We're going to see this later on. And the images that belong to the carousel itself. Finally, we need to run our carousel, and we do this with a small jQuery call. So we're going to use an expression inside our widget to do this. And here we have our expression at the end, at the bottom of our widget. The example string is set to start widget script. Now we did this in the previous video as well. This simply is what is shown on the canvas, and this is used as a canvas hint for what is being inserted here. We have escape content node because we have our value HTML code. Let's scroll up, and the HTML code inserts the script tag with the end script here, and in the middle we have the jQuery call that launches our carousel. So jQuery function $, jQuery function $, and then the element whose ID is carousel in the example, but in our case is not quite like that. The element whose ID is the carousel ID, and then from that element we call our carousel. So our carousel, here we go. And in this case, we're adding some more options which we can from an input object. Here we can see an example that we can pass an input object for the call of this function, and these are the configuration options that are available for that object. And we are passing some options to that object to adjust its behavior to the one that we need. And once we have this, on our home page, we just drag each of these widgets. So the jQuery import widget, the UI core widget, and the jQuery UI widget itself, and then the carousel widget itself is inserted here. Now, because these are actually dependencies, these three are actually dependencies of this one, you could just open this one and drag these here at the top, and therefore every time you insert the carousel, they are automatically added to the dependencies of that particular screen. That would be yet another option, a bit more reliable, so that you don't forget some of your scripts when they are needed. And that is basically it. So it's very simple, as you can see. In order to add a specific JavaScript framework to your applications, you just follow the rules of where to add JavaScript in the platform, use the best practices in terms of that, typically web blocks, following the manual from that particular framework to be able to replicate what the manual tells you is necessary to make the framework work. How do we debug JavaScript in web applications? Well, here we have our demo application. And the way to debug client-side code is using client-side tools. Now, the OutSystems platform does have some add-ons on the server side, on your environment, to generate standard code. Even on a server environment where OutSystems lives, it only generates what is standard code. You don't need any special plugins for your Internet Information Server or Java server. You will use those standard servers on your own. And the clients that access your applications don't need any plugins. They run standard HTML, JavaScript, CSS code. That means that there is no need for OutSystems to provide specific debugging tools for your clients. Now, on the server side, because the code that you typically see is not the code that is generated, it's actually diagrams of actions and so forth, we do have debugging tools specific so that you can keep looking at the code that you expect to see, the diagrams and the canvas and so forth, and see things happening there. You can single step actions and so forth. On the client side, which is what happens on the browser, and which is where JavaScript lives, there is no specific debugging tool provided by OutSystems. You need to use whatever is the best practice from the community. And typically, the best practice is to use the browser's debugging tools. So we go over here, more tools, and developer tools, or Control-Shift-I. Now, most developers will tell you that they prefer Chrome to develop, but these tools in a very similar fashion will show up in all major browsers. Safari has them, Firefox has them, Internet Explorer has them. They all provide very similar functionality. Now, we can locate things directly using this particular tool. For instance, I'm going to look for the expressions that are here at the bottom and are now invisible. Inevitably, they're in this div, which includes other stuff. So I'm going to click here and let's start drilling down to locate our stuff. And here we go. If we move the mouse here, we can find these divs, which are at the bottom. And when we open them, here we have our JavaScript, as expected. Now, the JavaScript is inside a div because when I created this demo, I actually placed all these bottom references inside containers. As you can see here, they are inside containers, all web blocks and expressions. But of course, this is not required. It was just a way to organize that bottom half of your screen to better explain what should be there in the canvas. And here we can find our JavaScript. Now, it's not the goal of this masterclass to explain how to use this debugging tool, so I'm going to skip most of the details and not get into what can be done with the debugging tools from Chrome, but I'm going to help you and figure out in which files and folders our JavaScript will be found. Now, we can see here how we can locate JavaScript in an expression. We simply drill down to the actual place or nearby the place where that JavaScript is supposed to be, and then we fine-tune our search directly here in the Elements tab. Some JavaScript is recorded on separate files. So let's go over to our Sources tab, and here we can find the folder for this specific module and application. Inside this folder, we have several root files and subfolders. Now, this root file is the built-in JavaScript for OutSystem. This is included in every single screen. We then have an automatically generated JavaScript file with the global module code that is present in every single screen as well. And you can see this here, the JS_in_module function, which we defined at the top level in our module. We also have another file, which is our screen-specific JavaScript. And we even have blocks. Inside blocks, there are multiple built-in blocks that we are using, but we're interested in this folder here, which includes our custom blocks, and in particular, our JS web block. Here we go. This is our JavaScript function in a web block. So these three specific locations, global to the module, screen, and web block, are generated onto a separate JavaScript file, which is included onto the generated screen, generated HTML, when this is sent over to the client. Not only these, but also our demo.js, which we included as a resource, and we asked for it to be deployed to the server. It's also here, JS in file, it's also here, and we manually asked for it to be included in the header in the preparation for our screen. So let's take a look at the elements again. We could take a look actually at the actual HTML code here, but it's easier to read in the elements. So let's go over to the head and see how this is all being included. You're going to scroll down. We have lots of meta tags and lots of links here to CSS files, and then we start having scripts. We have an inline script, and then the actual OutSystem script that you can see here. And immediately after that, you have the module global JavaScript. So this is one of the first ones to be loaded. It makes sense. If you have a global JavaScript code that is present in every single screen, then it likely contains underpinning framework and functions which will be used by other JavaScript code that is present on each screen. And therefore, it needs to be loaded first before the screen-specific code, for instance. So this is one of the first. We then have lots of blocks from Silk UI standard widgets being loaded here. Rich widgets as well. Lisbon theme itself, let's scroll down. Silk UI again, and finally, our own web block. This is our own web block code that's being included here. And then again, some more widgets. And finally, the screen JavaScript. Now, these two may seem odd. Web block and then screen. If we go over to the editor, we would think that this is the other way around. We have a global to the module, then a screen, and web block is something that you can include in screens. So you might think that the order would be this is the base, this is again something that builds on this, and finally this is something that needs code that is here. But no, it's the other way around. If you think about it, web blocks are reusable blocks, and they can be reused in multiple screens, and therefore they have the base code that each screen can customize. And therefore they are included in HTML before the screen-specific code. You should remember this, as it is important the order in which your scripts load. And that is basically what is important to know about debugging JavaScript in the OutSystems platform. Everything else is just standard debugging work. For instance, if I go now over to sources to set a breakpoint, and I open my demo.js, for instance, and set a breakpoint here, that means that when I start browsing and testing stuff, everything works, except when I get to the external file, which is this code here. And when I get to it, I trigger the debugger, and on debugger, I can take a look at local and global functions and objects. I can run JavaScript code to test things and so forth. Now, again, the way to work with the actual browser debugger is beyond the scope of this masterclass. So at this point, I'm not going to go into more details, but debugging JavaScript is the exact same process with code and applications that are generated by the OutSystems platform as it is using any other web technology. The OutSystems platform generates standard web applications. And once I'm done debugging, I just continue and everything works as expected. And that's it.